Hi, my name is Joseph Jenez, and I will be demonstrating how a simple DC motor operates. Right here we have a homemade DC motor connected in parallel. We have your field coils, we have your armature, and we have your commutators. I'll be using this diagram to help me explain how this DC motor operates. So, from the voltage source, the current flows into the field coils. Now these field coils, they replace a permanent magnet because the current flowing into them create a magnetic field due to Ampere's law. Now this magnetic field can also be known as flux density, represented by this B. Now due to Gauss's law of magnetism, we know that flux density flows from that magnetic north pole to south pole. We can determine these poles on this magnet, or the field coil acting as a magnet, by using Ampere's second right-hand rule, where we curl our fingers in the direction of the current, and flux density is determined by the direction of our thumb. In this case, flux density is traveling up towards the armature. Now, due to Bill's law, the flux density acting on this armature, along with the current flowing in because it's connected in parallel, create a force, also known as Lorentz force, that actually rotate this armature. We can determine the direction of rotation by also determining the direction of force using Bill's first right-hand rule. But instead of using our right hand, we'll be using this handy-dandy dice that Professor Chang Su made for us. This comes in handy a lot. So, using this dice, we know that the current is flowing to the left, and we know that flux density is pointing up. So by this dice, the force is going into the page, and for the motor, the force is going away. Now, if we were to change the polarity of this motor, by switching the positive and negative leads, we would actually see that the rotation would be the same. So if we were to follow the current again in the second scenario, we know that the current comes from the left, but then using Ampere's second right-hand rule, the flux density would be going down this time, and then the current would be coming from the left. Using Bill's first right-hand rule again, so current coming from the left, flux density going down, we would see that the force is still going into the page, meaning the force is going out. So that theoretically, that is how a DC motor operates, and we'll show you a quick demonstration of it right now. Let me just connect this motor. Bear with me, I'm only using one hand, and this is a homemade motor, so some tweaking may be required. So there you have it. It is spinning away from us, in that direction. Thank you for watching my video.